My name is Aditya.
I'm Chinmay.
And my name's Dipika. And the name of our project, our final project, was called Project ACE. And what our robot actually does is that we put cards into the platform and it deals cards for blackjack. And some of the problems and what our project is about that we ran into is that, well, first of all, our project deals the 2 additional cards, and it also hits players, and it can tell when a player wants to stay or doesn't want an extra card. Our original plan was to create a robot that would be able to deal cards for multiple games, but with the time that we had allotted for this project, we weren't able to accomplish that goal. We split up the work by having Aditya do most of the programming, and Chinmay did a lot of the construction. I helped with the construction, and some of the programming I also did. But we split up the work pretty evenly, and all of us worked together on every single step of the robot.
Alright, so an overview of how we designed the robot. There were a lot of robots online on YouTube, so I mean, we knew it was something that could be done. And we figured out there are a couple major parts that we needed. First is the card holder, where the cards are going to be, and a ramp that pushes them down, and then obviously the motor and the brick. So some of the constraints we had, the biggest one was, first of all, they're Lego pieces. You can't really do too much with them. Secondly, the ramp was a big issue because sometimes they push the cards down the other way, like they face the wrong way. That was a big issue as well. So our first design is, really basic. It had a pretty small base and the card holder on top. An issue with it was that it was super flimsy, and like just touching it, it would wobble around. So that was one of the biggest issues, and we need to change that. Our second version, we focused on making it more stable, which sort of worked. I'm not really sure what happened, but we also made it more complex and added the brick to it. And then in the third version, which will be right here, this is pretty much our final design. And it's a lot more stable than what we originally had, and we could still work on that, and that's one of the biggest issues, but this is what our final robot ended up looking like. Yeah, that's another picture, and you can see here there are stop and start buttons, stay and hit buttons. That's if you want another card, or you don't want another card, you can just hit those touch sensors. We added those at the very end, and that was pretty much a secondary feature.
So this is basically our code, and this is basically just showing everything that we initialized and all our variables that we had. We needed to do these because we needed multiple variables to call on into our program to tell it how many degrees to spin, how many players there are, and so on. And we started them off by making most of them equal to 0. So this part basically is like the code for the brick, and it lets us input the amount of players into the brick. So there's a display that says how many players, and you can press the up button to go up to 7, and then you can also read the down button and like subtract the players, and once you press enter, the code ends. And then this part of the code, what it does is it takes the player counter and it basically tells the motor to spin. It does 180 divided by the number of players, and so that's how many degrees it spins. And the first part of the code basically is the start and stop motors to tell it so that we can get 2 cards each, and then it spins. And this was basically the touch sensors. And the first part, if you say the stay button, it basically goes to the next player, it spins the X amount of degrees. And the second part, if you press it, it'll give you a card, it'll stop and wait till the next response. You can press it again to get as many cards as you want. So some software challenges we had were building the codes separately on separate files was fine, it worked, but when you try to combine them, we ran into a lot of issues, a lot of errors. We didn't know where to put which part because we had to run it in a specific order. So if something was out of the loops, it was hard.
Alright, some of the hardware challenges. I sort of discussed this before. There's the ramp, which was a really big issue. And then, of course, stability. The wires also kept getting in the way because, as you know, our robot turns or pivots, so the wires would get tangled up with each other. That was another big problem that we figured out eventually.
So if we had more time, we'd obviously like to add, like in actual blackjack, the dealer's card always has 1 card flipped up. We couldn't add that feature onto it, but if we had more time, we'd obviously like to add that. It'd make the game more accurate to the actual game it is. Also, we would love to make our design more stable because it's more stable than before, but if you push it a bit, kind of wobbles. And we would like to also add the cards to be dealt faster. It's a bit slow, and just make it a bit more precise. The cards sometimes stick together, so you get 2 instead of 1 sometimes. So just those little things we like to improve on. Some inspirations we had where YouTube videos obviously gave us like the design of the base, and we had to improve on it a bit. But we had YouTube inspiration, and we both love, all three of us love playing cards, so this is why we picked blackjack. It wasn't the hardest. Thank you.